we know x minus 3 is going to divide that. Okay, then we should have is remainder is 0, and then the 4 terms together are going to be the Q of x, the quotient. Okay, let's find out the quotient. Copy 1 down here, 6 down here, negative 29, negative 12, 54. Okay, this is previously the polynomial. Okay, we take all the coefficients and down, put right here. Again, if it's minus 3, put positive 3 here. Synthetic division, if you don't remember, it's still not too late. Very easy to see how I did right here. Take 1 down, 3 times 1. You put 3 here, because 3 times 1 is 3. Okay, always add. Here you do always add. Okay, always do the addition. Remember again, negative 3 you put positive here. Take 1 down. Here you always do times. Okay, always do times. 3 times 1 put here. Add always 9. 3 times 9, 27. Always put the answer here. Always add negative 29, positive 27, negative 2. And then negative 2 times 3, always times. Put negative 6 here. Always add just negative 18 for the result, negative 12 plus negative 6. Negative 18 times 3, always times. Put the answer here. Okay, put the answer here. What do we get? We should have negative. Yeah, negative 18 times 3. That's negative 54. Always add, you get 0. So remainder is 0. Okay, this is the theorem we learned before. If you plug in 3 into this one, you get 0. Remainder is 0. The remainder of what? This f of x divided by this factor, x minus 3, you will get the quotient right here, and the remainder is 0. You see, that's exactly right. Remainder is 0. Okay, now we have the quotient for q of x. You plug in for 1 stands actually 1 times x cubed right here. 9 is actually x, 9 times x squared, and here is negative 2x, and here is negative 18. How do we know it was x cubed, starting with x cubed? Because previously it was x to the 4th. So here is always 1 degree less. It's because here you have exponent 1. Okay, you see 1 with 3, you'll get exponent 4. That's the reason. Okay, always 1 degree. Exponent is always 1 less than the previous one. Alright, so you have q of x now. Q of x is x cubed plus 9x squared minus 2x minus 18. Okay, after you get q of x, then you can, of course, you can find out that they actually have 2 ways. One way is similar to the one we did here. You treat q of x as f of x. Okay, then you know if it has a rational root, then p divides 18 and q divides what? 1. Okay, so you can treat q of x as f of x we did before. I don't want to go through that. I'll leave you to do it. Okay, here I do by factoring. You know, negative 18 is negative 2 times 9. And you can pull this negative 2 out. You group this first 2 and you group the second 2 and the last 2 together. Okay? Yeah, here you have a negative 2, here you have negative 2. If you pull negative 2 out, then you have x plus 9. Because if you go back, that's negative 2 times x, that's negative 2x. Negative 2 times 9, that's negative 18. It can go back. Okay? Right here you have x cubed is 2 plus 3. Here 3 is 2 plus 1. 2 plus 1. And you know you have x squared. So you pull x squared out. And then the first one, x cubed, has x left over. And here it has 9 over there. Now you can see x squared times x. That's 2 plus 3 is exponent 3 here. 9 plus x squared, you have a 9. X squared. So we do this one by solving the grouping, by using the grouping method. And then you see x plus 9, x plus 9. You can pull it out again. And the first one will give you is that x squared. The second one is negative 2. Yeah, basically you factor this one into this form. Okay, from x plus 9 is 0 minus 9 on both sides. You have x equals negative 9. From x squared minus 2 equals 0, you plus 2 on both sides, you have x squared is 2. Choose the square root, you have x equals positive negative radical 2. This tells us that q of x has 3 roots. Negative 9, positive negative radical 2. And f of x can be written in this way. This was f of x. So f of x has root 3, and then plus all those 3 roots, negative 9, positive negative radical 2. So f of x has 4 roots. It's because here it has degree 4. Okay? So here there are 2 major steps to solve this one. You have a p over q, find out possible roots by p divides constant, denominator divides leading coefficient. We like this one be 1. Yeah. If the equation like this, the leading coefficient is 1, make the case easier. That's the major step. Try some numbers to find a possible root. Yeah, to find the possible, from the possible roots to find some real root here. That's major step, step 1. And then after you are clear, you find one, you can basically lower down the degree from 3 to 4, from 4 to 3, q of x, by using the synthetic division. Okay, and then you can do the same way to lower down the degree from 3 to 2. Here we did it by lower down the degree from 4 to 3 by doing those steps. Okay, and then the second major step, we use the synthetic division to find out q of x. Okay, the third step, you can go back to repeat as you did for this f of x, and then the third step can also be different. You can do by grouping. Okay, and then if you can factor it out, you will find out the roots. Okay, so you can see here there step 1, step 2, and here is step 3. Or if you want to repeat, that will be another 2 major steps, similar major steps. Okay. Please review this one, and good luck with your assignment. I'll see you next time.